This one has some extra work to it because we've got time and we got depth of water. Okay, so we've got our depth here in meters and our time down here. Now you only need, if you know something is periodic in nature, you only need one maximum and the next minimum to figure everything out. And that's all that's given here. It's got a maximum depth of 8 meters at 430. So if I put 8 up here because that's going to be my maximum, and I need to put somewhere along time for 430, maybe I'll choose that distance, because later I'm going to have to go 6 hours longer, so 6 or so longer will be about that distance, about that distance. I'm just sort of estimating my spacing. How am I going to write 430 on here? Okay? Because it's going to be a problem to plot 430 when you go to your calculator. Good. 4.5 make sense instead of 430? Yes. Well, it's a depth, so that's how deep it is. So if I mean, you're thinking writing it as a -8, so you think of it below. But if you think of this as this is the ocean floor, and this is the water, you could think of it as 8 above that way too. So 6 hours and 12 minutes later, 10:42. How am I going to write that? How do we get the 0.74? So if we do 42 divided by 60, this reduces to 7 out of 10, which is 0.7. So we know we have a maximum here at 430, and then at 1042 we have our minimum. Those are the only 2 points that we have. However, from this, you should be able to tell me what the center line is. What value is going to be right here? Should be 5. Same distance to the maximum, same distance to the minimum. Okay? When is the next maximum going to be? $16.9. And how do we get the 0.9? Okay? And so you took the 6 hours and 12 minutes and said that's the same as 12 out of 60 is 0.2? Or did you take the fact that this was 6.2 here? Okay, so we notice along the graph that we had 6.2 from here to here. And since it has to be the same time again, adding 6.2 will get us to 16.9. And there's our next point. Now we could draw our curve through these points. We can even add the 4 sections in between. If it's 6.2 from the maximum min, this to here will be 3.1, which would give us 7.6, and 3.1 here would give us 13.8. So what part A says, we're going to write 1 for sine and 1 for cos based on this graph that we just drew. Again, for DAB C, the D, the A, and the B value will be the same for sine and cos. The only thing that'll be different is a starting value. So do we know our D value? What's it going to be? 5. What's our amplitude? And our period, if we think of this as our period, from 4.5 to 16.9 is 12.4. So our B value will be 2 pi over 12.4. So we can start writing out our equations. I'm going to leave C for now. I'm going to go y equals y equals. They both have the same amplitude. So we can put a 3 out in front. We're going to do one for sine, one for cosine. They'll both have the same B value, which is 2 pi over 12.4. I'm going to leave the C value out, and then add 5 at the end for my D value. So considering all of that, now we look back and say starting points. When I want to do sine, where does sine start? 0, which is the center line, right? Because now there's nothing at 0 anymore. But when it's an original graph, it starts at 0, which is part of our center line. So, and it starts at 0 going up. So if we want to use a positive sine graph, we could look for this point, or we could think back and say we could work backwards and do that one. Now, based on the numbers I have on my graph, I would probably use this point here because I know it lines up perfectly with the 13.8. So that, we have that answer already. That's moving at 13.8 to the right. It would not be hard to subtract 3.1 to get that other value. But since I already have a number, I'll use that one. For cos, cos starts at a maximum. There's my first maximum. Again, it lines up perfectly. Boy, my lines were a little bit off today. Lines up perfectly with 4.5. It's 4.5 to the right, so we would write minus 4.5. So now we can go to our graphing calculator, set up this window, type in our equation, and just do a quick check. Does it look like it's matching up nicely with this graph? So if I would look at that, I'm going to go to my calculator, clear these ones out. So quickly look at it to memorize it. 3 cos. 3 cos. Two pi divided by 12.4. Oops. Another bracket. X minus 4.5. Bracket. Bracket plus 5. Go to my window. We need up to 16.9, so I'm going to go up to 20. My y min goes up to 8, so I'm going to go from -1 to 10. The fraction thing, you can go, you hit the alpha button and y equals, and if it has the newest operating system, it'll come up as one of the options. That one might not have it yet. Then you just have to go 2 pi divided by. That looks about right. Estimate at 1:30 p.m. Okay. 1:30 p.m. How will that show up on the bottom of our graph? Will it be at 1.5? 13.5. Why 13.5 and not 1.5? Because we're looking at PM, right? The 4:30, when we look in the context of our question, the 4:30 was in the morning. 13.5 would be right about here if I'm estimating it. Now, I don't know if I can really trust my graph too much for estimations because of all the lines that were off, but I'm going to guess 3. Think that's too high? 2.1? 2.7? 2.7? You like that one? Okay. We'll go with our estimate at 2.7. Now that we've typed it into our calculator though, we can find it exactly. Second trace to get to our calculate menu. Value at 13.5. 4.5. Man, my numbers were way off. So the actual answer is 4.5. Perfect. Okay, so there's a couple of questions after that that say practice on your own. You can do those now to check your skills at this. Some of your papers say homework at the bottom. A lot of them don't. You can stroke out that homework because you don't have that sheet. If you want more questions, from 6.7 in the textbook, I'll tell you some numbers that you can do. All the questions from 3 to 9 you can do as practice. That is at the end of 6.7, so it starts on page 548.